I was very excited to be in between Dave and Catherine. I was like the meat and the sandwich, and then Richard told me nobody puts the boring bread in the middle of a panini, and he's probably right. George Koperna, I'm a reservoir engineer with Advanced Resources International. I've kind of had two introductions earlier, so I appreciate it. And I'm going to talk about the boring bread. We're here really to let you know where we are in our permitting process, describe it, and kind of shine a light on what's going on in the U.S. in terms of our regulatory framework, particularly in light of all the activity that's going on, and maybe to sprinkle in some thoughts about how that's evolving, right? Because having a regulatory framework is one thing, testing it with projects is really another. And so we're learning a little bit about that. And so Richard's mentioned the US EPA, our Environmental Protection Agency. They're our cognizant regulatory authority. And we have two steps in the US. It's permission to construct our injection well, which is predominantly what we're going to talk about here. And then once you go through that original permit application, which is allegedly 18 to 24 months, and if you're in a very busy region, as Richard suggested, maybe 2 to 3 years. Louisiana certainly has a number of permits that are in the pipeline that are really probably going to stretch that timeline out. Where we're operating in Mississippi, I think there's only one or two others, so we're feeling we're getting the attention we need. Once we get that permit, the next step is to construct that injection well and get the permission to operate it. And that'll probably require any gaps that the director recognizes, as well as, and Ingvild will probably talk about this later, probably characterizing the CO2 stream, among other things. And so there are some challenges with our stratigraphic wells. We've drilled a number of them across the U.S. They've kind of fall in, Ingvild and I worked on a paper called donut holes. And so they kind of somewhat fall in a donut hole in various states. In some states we need a permit for them. In other states they're unpermittable, meaning they're not for purposes of water extraction. They're not for the purposes of oil and gas exploration. Those boards have no cognizant regulatory authority. So we've actually drilled, Dave and I, a few stratigraphic test wells in the U.S. that don't require a permit. As people who come from the oil and gas industry, that gives us a little bit of pause, but we're very careful and make sure we keep all the paperwork we need to. And so what I'm gonna lay out for the rest of the presentation is really focusing on our Mississippi project, focusing on the application that we've put together. And there are several resources that the EPA has, and you'll understand why we have all these resources when I point to the next slide. But they've given some guidance documents for the various plans that you need, an outline of what that permit might look like, some various checklists, computational tools, meaning you have to look at liquid rise and abandoned well bores as a threat for your injection pressures, as well as what other permitted Class 6 wells are about. And so why do we need all of that? Well, there's a big old list of all the things that we have to do. And you see a bunch of highlighted things in there: financial responsibility, testing and monitoring plan, well plugging and abandonment plan, all things that you would think would be part of your permit application. And when you look at it like that, it's overwhelming. And it is. And I shamelessly stole this from Ingvild. I changed at least one letter on it somewhere, so it would be mine. Nevertheless, you're looking at something that to create these plans takes 4 to 6 months, and that's soup to nuts, and then you submit it. And then the process is such that the US EPA will review your permit application, and if it's administratively complete, meaning no technical review, just have you given us everything that you need to provide us, yes or no. And if you haven't, they'll put a request back for a few missing items or clarify a few things. And if you have given them everything, then they start their technical review. And so that's kind of the process. And 18 to 24 months after that completeness review is when you go through your entire process for your permit. How I like to look at it is a little bit differently. Those are the key plans that you need. And if you look at that, how did you characterize the site? What were the results? What is the area review? And the area review is we're going to inject this much CO2 at these places. How does the plume develop? How does the pressure plume develop? Which is greater? And you build your area of review based on that. And that area of review becomes kind of your monitoring area for your project, which feeds into your testing and monitoring plan. You have how you're going to construct your wells. Obviously, we need to have materials and cements that are impervious to that CO2 integrity challenge. Any tests that we might do pre-operation, meaning, are we going to do a well test in our injection well before we operate it? Are we going to do any kind of other pressure buildup tests to make sure that we have casing integrity and things like that? All of that, and logging. If we're going to do wellbore geophysics, we'll include that in there. Post-injection site care and site closure plans, meaning after we cease injection, say 30 years down the road, what are we going to do in that period of time to demonstrate that the CO2 is where we said we were going to put it and it stayed there? And how are we going to demonstrate that? How we're going to then abandon those wells, including our monitoring wells in the project. We build out an emergency and remedial response plan. What is that? Well, some key scenarios, things that might happen. For example, you might have a casing leak or something like that. What might be the steps and the procedures that we would do to go through to repair that? And based on our risk assessments that we'll do, we'll identify, well, maybe 24 likely events that will happen that would be field remedial events that we'll lay out response plans for. Each site's different. We cater it to the risks of the project. And then the financial responsibility, which is kind of the big one, that if ARI or Southern were to operate this project, right now it's Mississippi Power, I believe, were to operate this project, if they were to go away, what would the EPA have to pay someone else to come in and pick up the project and close it out? And so we'll talk a little bit about each of those items. So we've already seen kind of the maps. Let's zoom in at the site. Up in the upper part, kind of in the beige, is kind of where Plant Ratcliffe is. About a little more than 6 miles to the south and west, you see where we have a well field. The 2 red triangles will be our proposed injection wells for the site. Each one to accept about 4,000 metric tons per day of CO2. As Dave pointed out, we're only looking at the lower Paluxy, but that sand is suitable to take all the CO2 in these wells and more. So it's just under 1.5 million metric tons per year per well is what we're permitting. Now, that's more than what can be provided by Plant Ratcliffe, but that allows us some opportunity that if others were to come to the site, we could accept that CO2. Certainly, you could permit additional wells and expand the well field, and also move up vertically in some of those shallower sands. The yellow dots represent some of the monitoring wells that we've drilled, all 6 of them. And I think about 18 months ago, Richard, I was with you, that we overdid it. It was a science project. But in our experience now working with the EPA, what we're finding is demonstrating that you really know the subsurface in a significant way is a key to easing this permit pathway. And Dave mentioned a couple benefits of having these, converting them to monitoring wells, for example, to save money. And then we're skipping the seismic, so that gives us a nice well field. But we've now drilled 6 wells, taken all the data that Dave's shown, and that gives the EPA confidence that we are experts at the site geologically, and that if we drill another well, we're not going to get a different answer than what we're providing in terms of our geologic characterization. And that certainty is what the EPA is looking for. We've submitted our first application for the well in October 2022, so a long time ago, but at that time we didn't really know how to do working with the EPA. We have 2 wells in our area of review. We thought we had to do 2 different permits, so we were going to submit one and then clone it and submit the second. And fortunately, the EPA came back to us and said, well, look, as long as they're in the same area of review or the same impacted area, 1 permit for both wells. And so we modified our permit everywhere we had well 1. We had now well 1 and well 2. And so that took some time. And we submitted that in March of 2023. It went through, they had a few minor questions. What other permits are associated with this? And I think that was largely the permits that we would have had at the capture facility. So we addressed that, corrected a few typos, and it was deemed administratively complete, and we're now in the technical review process. So our boring engineering slide, and this is the reservoir model and how it looks. It's a tartan grid, and you can kind of see the well field that we've laid out. And you know, one of the things is what happens at the boundary conditions, and we do those well tests. And when you have permeabilities that are approaching 3.5 darcies, a 24-hour well test explores a lot of the subsurface in terms of time and radius investigation. And so what we're seeing is that those sands, even though they're massive vertically, they are interconnected all the way through, and we're not really seeing any bounding effects. Dave said it's a very boring subsurface in terms of faults and that type of behavior, but we're also seeing that in terms of the well test to back up our modeling grid. Won't go through it, but we use GEM, which is a CO2 compositional model that CMG, the Computer Modeling Group in Canada, sells. So it's commercial. It's predominantly used in oil and gas. It's what we use for our EOR projects. The CO2 modules in it are excellent. So it is basically a flow model that we're looking at, but it does do some of the fate and transport if we choose to really look at it in terms of thousands and thousands of years in terms of mineralization. When you look at it, we divided the Pluxee in 4 big segments, and you can kind of see that here. It is massively thick, but it's 4 major lobes, and you can kind of see them in the 3-dimensional plot, each subdivided, which gives us some confidence in terms of the grid and CO2 developing. If you look at the dip, Dave said it was kind of north, shallower to the north and east, and you kind of see the dip of the models moving that way. So CO2 is more buoyant, especially at 1,500 to 1,800 meters. And I think what you're seeing is as you move that depth at those permeabilities, it tends to want to move into the path of least resistance, which is CO2 is less dense than the brine, so it's moving in the upper lobes more preferentially than the lower lobes. If we were to target just the lower lobes, of course, we could get the same kind of benefit, and we did test that out. But the image on the your right, that's just the plume development, our area of review over time. And as you move from the red to the yellow, you can kind of see through the injection period, just building volume in the subsurface to then our relaxation after injection ceases in your post-injection site care. And ultimately, that was about 2.7 miles or roughly, almost 5 kilometers, and something like just under 17 square miles of total area. Testing and monitoring plan. How am I doing on time?
You're good. You have 8 minutes.
Okay, good. Dave talked a little bit about that. So I've taken what we've said our impacted area or our area of review, which is the EPA term, and that's kind of that figure 8, lazy figure 8, if you will. And you can kind of see we're fortunate that we did plan to drill our monitoring wells and our stratigraphic test wells in good locations. So they're generally outside the plume. Regulatorily speaking, we have to have a couple of above zone monitoring wells, and you can kind of see we have 2 of those, and they are the yellow circles here,
Yeah.
kind of concentrically, I know, but pointing that thing's going to take forever. And we have all the in-zone monitoring wells that we're going to have. And those above zone monitoring wells, Dave mentioned, we're going to track that water quality annually. Less so in the far field wells. They're largely going to be pressure. We've had a lot of success with pressure monitoring. With this kind of arrangement, we'll get it in multiple distances and multiple directions from our point of injection. So really refining our numerical models will really be helpful. And this helps us build the case that we're going to be very careful with this. 3D seismic is challenging here. All the things that Dave mentioned in his characterization plan, You do it again, that becomes monitoring, right? So that second, third, fourth time, a lot of those tools that we're deploying for a characterization purpose, we're going to deploy for monitoring. And because we have to protect the groundwater, as Dave said, we have a number of shallower groundwater monitoring stations that we're going to have. And they'll be deployed on the well pads that we develop to try to ease the impact over this area. So using downhole logging tools, pulse neutron logs or RSTs, depending on which vendor you're using. I forget what Baker calls theirs, but we're largely going to deploy those to kind of look for CO2. Obviously, we're going to be looking at injection rates, injection pressures, and whatnot at the points of injection, as well as monitoring annular pressures. That'll be regulatory required. Differentiation then shows that there might be a leak or something, so that's what we're really watching for there. And then a lot of that's going to be real-time monitoring, so I think we're going to have data people at some point to really handle this wealth of information that's coming in, and we're going to have people that can really respond to anything very quickly. So that's going to be a new challenge, I think, when we start looking at these massive, massive data sets that you're collecting. The well constructions, really quite boring. They're fairly shallow wells, 1,500 to 1,800 meters. We are anywhere that might be impacted by CO2, we're running Chrome 13. And so we think we can get these volumes down 4.5-inch Chrome, 1.5 million tons a year per well. So you're going to have a pretty large well if you work back from 4.5-inch tubing all the way up. And so quite significant, but the monitoring wells will probably, that are far field, will run the Chrome up to the primary confining unit, and then mild steel, therefore, all the way back to surface. So it won't be fully Chrome in those wells. Cement from TD to surface in all our wells to be compliant. And I think, yeah, that's pretty much it. And so here's kind of what the post-injection site care and plume development looks like. At these rates and these permeabilities, as you'd imagine, the CO2 moves out much further than the pressure plume. 3.5 Darcy's, I think our maximum injection pressure was at the wellhead after 30 years was only 80 pounds over native pressure. So it's just taking it, and then buoyancy is moving the CO2 in the subsurface, and you can begin to see that as it develops. Yeah, I think you're going to get these slides when we close the site. We're going to abandon those wells. We will cement them from TD to surface. We'll literally fill them full of cement, and that's one. Our client, who is Mississippi Power, kind of likes that. It's risk averse, right? It's not a conventional oil field abandonment, which in some cases isn't suitable for CCS. And so it's above and beyond the call, but we know that we filled that borehole with cement and the risk of leakage is insignificant. We talked a little bit about the pre-operational testing plan, so in the emergency immediate response, so I'll skip that. But I will spend just a second to kind of leave up that financial assurance slide, because this project, because there's only 2 injection wells for that volume and those monitoring wells, the financial assurance requirement is about $27 million. So corrective action is 0 of that. And that's because this is very much a greenfield. We talked about drilling a whole bunch of wells. That's kind of easing our ability to manage wells that aren't ours, because there aren't any in this entire area. The nearest well is well beyond where we've drilled. So the plugging program's $500,000, post-injection site care, so it's largely the monitoring, would be about $19 million, and then the emergency remedial response planning would be almost $8 million of that. So it works up to about $27 million. This is where we are in the process. It's been deemed environmentally complete. We're starting to get technical questions now, and we're in our 2-month window. I believe we're responding back at the end of next week with our first round of questions on about 6 or 7 of the plans. It's largely consistency driven, a few typos and things like that, so nothing really shocking or out of the ordinary. What we expect here is it's a few additional questions to come after we provide these answers, and then we're going to move into the rest of the process on the remaining plans. One of the key things that we were kind of surprised to see is the narrative the part of the applications that describe the entire project had in it the well construction plans and the injection well operation plans and the geologic characterization report. And it was a pretty big document, and the EPA asked us to separate those out. So I would expect they're learning that when they want to be able to share these pieces, because not every reviewer is going to read every plan, so it helps them to kind of parse that out. Real quickly, I think I got maybe just a few minutes left.
Yeah, 2 or 3.
But I wanted to talk about the connected activities. We're seeing questions on other permitting plans about, hey, have you looked at any of the historic preservation data? Have you looked at any cultural resources, et cetera, et cetera? It's not part of the US EPA requirements, but they want to make sure that the projects are doing this. And so because this is part of a government-funded or a publicly funded project in the U.S., we have to go through the National Energy Policy Act, which is environmental compliance. So we create an information volume on the environment here, send it to DOE, and they say, all right, you don't have to do anything else. You get a FONSI or a categorical exclusion, finding of no significant impact, or prepare an environmental assessment or prepare an environmental impact statement. So we had to prepare an environmental assessment, and we're working on that now. And that included some of the movement, or what loosely call it a pipeline. It's more of transportation infrastructure from the capture facility to the field. It's only about a few miles, as you can see. And there's our timeline. We submitted that in, March of 2023, and we're working on continuing that process now. And I think we don't have to go into the last slide, but I'll just put that up. And hopefully that leaves enough time for Catherine.
The last slide is the thank you slide.
George, I'll mention just one quick thing. Mississippi Power is a Southern company. So you're hearing the term Mississippi Power, but Southern Company is a corporate company of a whole bunch of operating companies. So when George says Mississippi Power, it's Southern.
One and the same.